Hello, everyone. I hope you can all hear me and see me, and as long as my presentation, please do let me know in the chat. So always in my sessions, I tend to make it very interactive. So it would be great if you can let me know on the chat if I'm audible and I can see my presentation as well.
Yes, we can see everything.
Perfect. Very good. Thank you very much. So thank you for having me. My name is Mahmoud Elhussainy. I'm a solution architect with AWS based in Dubai. I joined AWS back in 2019. The session I will have for you today is mainly to talk about introduction to AWS and what does it mean to have a cloud, and what does cloud really means, and AWS when it comes to an overview. So I think the very basic questions that we are trying to answer really when we talk about cloud is what exactly is cloud? What does it mean to have a cloud? For us at AWS, cloud means the on-demand delivery. And the keyword here is on demand. So just like any basically a service that you're getting at your home, electricity, water, internet, it's all on demand. And the way for us, we want to make sure that any component that you may need to build an application or to serve your IT agenda and objectives, you can always get these resources available for you on demand. You don't have to forecast what you will need for the next 3 years or 5 years. All the resources are available for you. So it's on-demand delivery of IT resources, any resource you may need to power your IT, whether this is a virtual desktop, you need it for machine learning, you need a server, you need storage, you need backup, you need DR, any resource you need for IT will be available for you on demand. To access all of these resources, the default option is to use the internet. So all you need really is to have an internet connection for you to be able to access all of these resources via the internet. And the way billing will go for this, it will be following the pay-as-you-go model. So just like what you have at home, the more you use electricity, the more you use water, the higher the bill will be. And when you no longer need these resources, just like with AWS, you only pay for what you use. When I no longer need these resources, you power it off, you give it back to AWS, and you stop paying for them. Literally $0 once you're no longer using that service. So now that we identify what is cloud in general, where is the story from AWS all started? So AWS started back in 2006, and AWS was the first public cloud provider at the time. And what happened at that time is we know Amazon started back in so more than 20 years ago. So back in 1995, 1996, when Amazon was started, Amazon.com, the retailer that we know today, they, just like any IT organization, they needed lots of things from their data centers, from their applications. And just like any corporate and any enterprise, they faced lots of limitations. It took them 6 months to transform an idea into a product, into an application. So back at that time, they started building multiple data centers across the globe. They started making sure that the services available in these data centers can be consumed by application owners rather than waiting for multiple months for hardware to be provisioned. So by 2006, so you're building up like 10 years, 2006, they decided to actually let that infrastructure be public to help all organizations globally use our infrastructure to also help their IT organizations to develop and build applications and focus on what's really important to them, which is not building data centers. So your main objective is to run your applications. You want to make sure you get to your clients faster and quicker and in a better experience. It's not your core business to build data centers. So this is a little bit of history from AWS back since we started in 2006. Now, why would customers today use cloud?
Sorry, Mr. Mahmoud, to interrupt you. Are you moving your slides?
So I'm moving now from a slide that says why, what is a cloud, to why is cloud. Do you see why is cloud?
We just see introduction to AWS. Now we see
Perfect. Okay, very good. So why is cloud? Very good. Thanks very much for catching that. So why cloud? Now, in general, we see multiple customers using cloud for different reasons. The ones I have on the slide just summarizes the top reasons that we see with our customers. Reason number one would to increase the agility. And agility here means how much time do you need from the minute you have an idea to actually having a product launch. So typically on-premises, that experience can take months, like 3 months, 6 months, because you still need to provision hardware, racking and stacking, lots of configuration that needs to be done. And then you give these resources to the application team to start actually building and testing their applications. Now with cloud, I don't have to do all of that. So now if I have an idea, I can immediately tap into the cloud and get as many and as much resources I need from that cloud to start actually building my first testing environment and develop my application. So increasing agility, increasing performance. So if I need to have more performance today for my application, I don't have to wait for more hardware. I can just get that extra hardware now from the cloud. The second reason is with cloud, with AWS, you can nearly scale your application to virtual unlimited resources. So we have customers who have tens of thousands of servers running on AWS. The more you need, the more you use on AWS, we will never tell you there is no more capacity in our cloud. We have global customers using AWS who are using even hundreds of thousands of servers. So you no longer need to think of scalability really when you are building with AWS. The third most important, dominant reason is reliability. When you are building on cloud, when you are building on AWS, you will experience much better uptime for your application compared to trying to building it on premises. The reason why that is because on AWS, we take lots of the responsibility of building and maintaining the infrastructure, leaving you to focus more on the high availability of the application. So the more responsibility pushed to AWS, the more we make sure that the infrastructure is reliable and you have a very good uptime for your application, even better than what you can build on premises. The next reason is lowering costs. Now, many IT will not really put lots of attention on that, but for business owners and for many CIOs and CTOs, being able to reduce your pricing while being able to have better agility and unlimited scalability and improving reliability is a huge plus sign. The reason why you are able to lower cost on cloud is that you are only paying for what you need. You are only paying for what you use. Any IT resource you no longer need, you simply give it back. Even the licensing model of any third-party product on AWS, like Windows, for example, is also pay as you go. So if I'm powering on a Windows server on AWS with the license included option, I pay per second for that server. When I power it off, I no longer pay for the server. I no longer pay for the Windows operating system license. So it gives me the ability to actually put my money, put my budget where I really need it. Now, having all of this while maximizing security. This is what it means to be running on AWS. Security is the most important aspect for us. It's our #1 priority, or what we call here job zero, is that the privacy and the security of the data of our customers are our top priority. Now, many people will think if I move data to cloud, it could mean less security. The facts are customers moving to AWS found out they're actually more secure running their applications on AWS than building it on premises or running these applications on-prem. So the facts that it's actually going to be more secure to run it on the cloud on AWS than keeping it on-prem. Now, as a testimonial of actually having a third party evaluate the AWS offering compared to competition, this is basically a snapshot of the Gartner Magic Quadrants for the cloud infrastructure vendors. And that you can see here from that report that AWS has been positioned the top leader in that report. I am putting for you a link in the slides where you can have a free version of that report. You can see why Gartner evaluated AWS and the other vendors, what criteria did they use, and why AWS was positioned the top leader. Also, interestingly for you to know, AWS was positioned the top leader for 11th consecutive years. So every year when Gartner started making that report, AWS was always positioned the top leader in that report. But when you actually dive deep into the report to find out why AWS positioned like this, you'll find multiple reasons. And I'm just going to break them down very quickly with you. Reason #1 would be security. I said security is the most important aspect for us. And this is the data points that shows why. AWS supports the highest and the, let's say, the largest list of security standards and compliance certification than any other cloud in the market. So if you're running, let's say, a sensitive application that has credit card information, that have human names, it has addresses, mobile numbers, and you want to make sure you are running at the most strict security standard, then running on AWS infrastructures helps you achieve that goal. Now, the second piece I want to talk about from security is only on AWS, where you will find every single service that stores data, whether this is a storage service, analytics, machine learning, whatever service it is that stores data, you will always find the option to encrypt this data. So every single service where data is stored has encryption. And with encryption, you have lots of options, including manage your own keys. You want AWS to manage and rotate the keys. There are lots of options available, but you always have the encryption available for anything to protect your data. The second reason AWS was positioned the top leader was because of the depth and width of our services. You see here on my slide, basically a sample of some of the services and the categories you will find on AWS. Now, of course, we do have some foundational services like compute servers, storage, networking, security. All of these are very basic and very foundational, and you will also, of course, find it on AWS. But then you move on to the next layer. You will find abilities for you to build containers and microservices applications. You will find abilities for you to build a proper DevOps and CI/CD pipeline on AWS. You will find multiple security and advanced security prevention techniques available on AWS, including DDoS protection, web application firewall, how to detect if I have a ransomware running in one of my servers. So all of these advanced features, you'll find them available as well. All the way till the state-of-the-art services in machine learning, talking about analytics, talking about business intelligence, talking about game development. If I want to create a game today, and I have an idea of a very good game, I have the ability within AWS platform to build my game, test my game, and then publish it to Android and iOS and all the different gaming platforms that you would have commercially. Whether it's IoT, whether I want to focus on media, whether I want to focus on something like blockchain technologies, whatever it is, you will find it available on AWS. And I would like to say the reason why we have the biggest width and depth for our services actually comes back for our leadership principle being customer obsessed. You may hear about customer obsession a lot with AWS. Being customer obsessed is translated in AWS in our roadmap. 90%, that's 90%, 90% of what we build at AWS is based on direct customer requests, which is why you will see here in every single category, AWS is always able to offer their customers the highest number of services, biggest portfolio of features, because we listen to what our customers want. We don't develop features and then try to find customers for it. It's the other way around. We work with our customers. We try to understand what do they need to actually make their application faster, quicker, at lower cost, and then we build a service for them. And then we make it available to all customers globally. The next reason you will find AWS positioned as the top leader is the resiliency or the uptime. This is a report that was published recently about the downtime reported from all the cloud providers, and the lower, basically the better. So AWS reported the lowest number of downtime hours compared to any other cloud providers. That means by running on AWS, you have the most reliable infrastructure that powers your workload. Now, you will have all of this material, so you can always dive deep more in why and what sets AWS apart in the market. But I think if I'm going to summarize all of these reasons and all of these achievements, I think it all goes back to being customer obsessed. Our ability to listen to our customers and help them innovate and work with them to develop and build their applications. Now, talking more about the AWS infrastructure that we spoke with, we have the biggest, again, portfolio of infrastructure. So when we talk about our infrastructure at AWS, we talk about regions and availability zones. So let me explain what that means. Now, globally, we have 26 online regions available, online available for you today. So you can see them in the map. The ones that are highlighted in white, these are existing regions, and the ones that are highlighted in orange, these will be coming soon. So we have 8 regions coming soon, including the UAE region that should be coming very, very soon, talking about a few days for this region to be online. So globally, you have 26 regions. Each one of these regions will operate within the physical borders of one country. So let's talk about the nearest one we have, let's say in Bahrain, or the one that will open in the UAE. Each one of these regions will have inside it multiple availability zones. Now, the definition of region in AWS and availability zone is different than any other cloud provider. Each one of our regions, the 26 globally, and all the 8 that's coming soon, will have multiple availability zones. Typically, it's 3 availability zones. So Bahrain has 3, Cape Town has 3, the UAE will have 3 availability zones. Okay, what are the availability zones? Availability zone, each one of them is a cluster of data centers. And each data center has hundreds of thousands of servers. So imagine having a cluster of these data centers together, then this is one availability zone. And then we build 2 other availability zones to total 3 availability zones that are physically separated from each other. Physically separated. So you are talking up to 100 kilometers away from each other. So 3 physical availability zones far away from each other, but all 3 of them are inside the same country. So for compliance reasons, all the data that you will use across all the 3 availability zones will reside in one country. It will never leave the region. It will never leave the country. So let's take a step back. Bahrain and UAE will have 3 availability zones each. Each AZ has multiple data centers. Now, we said the availability zones are physically apart from each other, up to 100 kilometers. However, they are also connected with each other. Like you see here in my slide, they are physically connected to each other with high-speed redundant links that delivers usually 1 or 2 millisecond latency between the availability zone, which allows us to do what we call synchronous mirroring, meaning any data that you will upload, let's say, use one of the, let's say a database option, and I want to make sure I run my database in one of the availability zones, and I want to have a highly available version of the database that runs in another availability zones, I'm able to replicate the data between the availability zones synchronously. So if one AZ goes down, I have all of my data on the other availability zone, 0 data loss. The same thing for our storage services, something like S3, which is our object storage. If I upload something as simple as an image, a picture, a selfie, if I upload this to S3 and I choose to put it in Bahrain region, then that picture is already uploaded to all 3 availability zones inside Bahrain. So even in the unlikely event of losing one availability zone, then as a user, I don't see that. I can still fetch this picture if I need it, because the other 2 availability zones are still online and available for me to retrieve this. So you have the highest availability, you have the highest reliability really to get my data back. So it's a very important choice when you are making which one of these 26 regions are you going to operate for your application. And whatever region you're going to choose, your data will never leave this region by itself. If I choose to put all of my data in Bahrain or Ireland or the UAE region once it's open, the data will never leave the region by itself. Maybe for a DR purpose, you want to mirror your data between UAE to Bahrain, but this is your configuration, this is your choice. But by default, the data will never exit a region by itself. I hope this is clear. So the first thing we wanted to discuss in infrastructure was regions and availability zones. Globally, let me go back to my map. Globally, we have 26 regions and 84 availability zones. So you can see that factor of 3 is showing up a little bit, that almost every region will have 3 availability zones. Some regions even have more than 3. But let's say for the average, for most of the regions, it's 3 availability zones. The second aspect of the infrastructure that we have globally, and again, it's considered the biggest, is our edge locations. You can see on the map here, sample of some of the edge locations we have globally. An edge location for us is allowing us to do lots of features, but the one I'm going to focus on is caching. So let's say you are building a website, and we are talking about sustainability. We're talking about climate change. We're talking about how we can protect our planet. Now, if I choose to build a website and I operate this website in any one of the regions, let's say the Bahrain region today, that means anyone globally needs to go all the way to the server in Bahrain to retrieve my website. So that packet will need to go through the entire network, the internet pipeline, all the way to Bahrain so that I can get that website. However, I can choose to cache my website into some or all of these edge locations you see here on the map. So if I know I am serving this website to global customers, then I want to make sure my website is cached. So if someone, let's say, is in the US or Australia and they're going to access this website, they can always retrieve this website from the nearest cache. They don't need to send the data all the way to Bahrain to get it. Okay, very good. Now, another aspect is again very unique to AWS is the way these regions and these availability zones and all the edge locations are connected to each other. One unique aspect about AWS is that all of these infrastructure components are connected together using our own AWS backbone network. There are no third parties in between. There are no third parties in between. So even the cross-oceanic cable between US and Europe, between US and Asia, all these cross-oceanic cables, all this entire infrastructure is operated and managed by AWS. That allows us to control the SLAs that we offer to our customers and the uptime and the service level agreements that we have. So all of these are 100 gigabit per second links to connect all of our regions together. And another side note, all of these links are owned by AWS, meaning traffic between one region to another region or one region to the edge location is not exposed to the internet. So if today I'm running in Bahrain, I'm doing my DR in the UK or the UAE region, traffic between the regions is not exposed to the internet. This copying of data between two regions, if you choose to enable it, will be private using our own internal AWS backbone network. So this is a huge advantage to AWS. And again, it gets us lots of credit when it comes to the security pillar and compliance. Now, talking more about the Middle East. So currently, as I mentioned, we do have one region that's operating currently in Bahrain that has 3 availability zones, and this has started already since 2019, and we have many customers in the region who have been using it. But in addition to this one, we also have an upcoming region in the UAE that will have 3 availability zones. So you have a full-on region in Bahrain, another full region with 3 AZs in the UAE. And as I mentioned, when you choose to build an application, you have to choose a region. And then from there, you start building your application, and the resources that you assign, whether compute, storage, and so on, will always reside in that region till you decide to replicate and move these workloads to another region. Now, again, focusing on our region in the Middle East here, North Africa, you can see here a list of some of the customers that are today using AWS. Now, I am sure you will find some of these names familiar to you. You could be using some of these today. Now, for myself, of course, I'm using Kareem. I'm using on that list, of course, I'm watching lots of content on MBC and Shahid.com, who is on AWS. You will find yourself hearing music on Anghami. You could be seeing yourself getting your parcels and shipment through Aramex. So really looking at that list, you will find that all the major enterprises in the Middle East are today using AWS. Whether the list of the names you can see here are enterprises, some of them are startups, some are even government entities that are using AWS. So making the theme and moving a little bit to the climate. So in 2019, we co-founded the Climate Pledge, which is basically a commitment that we are making to be net zero carbon across all of our businesses by 2040. And this is not just AWS, this is Amazon globally. And if we are able to reach this goal by 2040, that will be 10 years ahead of the Paris Agreement. Now, How does that basically translate to what we are doing today? Let me go back a step. So today we do have a path at Amazon, at AWS, to reach 100% renewable energy by 2025. And Amazon is already investing more than $2 billion as part of that pledge fund. Now, talking more about AWS and talking more about cloud. Now, let's say a customer is talking to us about, okay, so having a region from AWS that also generates heat, right? That needs cooling. There are power to actually power that AWS data center, correct? But studies found out, third-party studies, that actually migrating and operating an application on AWS is actually gonna generate 88% less carbon dioxide compared to running the same workload on premises. 88% less carbon footprint by just moving to the cloud, moving to AWS. Now, when you really think about it, I think it would make sense, because when you think about your own data center and the amount of power that goes into your data center that you are not using 24/7, none of the workloads, none of the hardware that you have actually is used to 100%. But by moving it to AWS, you are making sure you contribute to saving the planet and reducing your carbon dioxide. So it's always more sustainable to run a workload on the cloud. This is why recently we made a change in our well-architected model. Now, I know many of you will be building applications on the AWS and on the cloud to help save the planet. And we used to have 5 pillars that we take into consideration as part of the solution architect role that I'm currently in, or any developer or any application owner that builds applications need to consider all. Used to be 5 pillars, now it's 6 pillars before building this on the cloud. The 5 pillars to build any proper application could be something about operational excellence, which is more about how that workload will be automated. How can I make sure that I don't operate it manually? I need everything to be provisioned and maintained and even decommissioned automatically. The second most also pillar is security. How is this workload secure? And you're talking about the entire layer of security. I'm not just talking about network security, talking about all the other layers. I'm talking about DDoS protection, I'm talking about encryption, talking about governance, all of these things. The third pillar is reliability. How can you build the application to become highly available? Everything fails, even on the cloud. A server can fail. A rack can fail. Even one availability zone, let's say, probably can fail. But when we build an application on AWS and we take all the design principles of the reliability pillar, we make sure that this application will have the utmost uptime, regardless of what failure will happen. Whether the front end, the back end, the network failure, server failure, your design should be able to take all of these failures in and automatically heal without causing any downtime to the end user who's using my application. The pillar number 4 is performance efficiency. And I think this is very critical, again, to the sustainability also. Performance efficiency is always making sure you are choosing the correct tool from AWS to do the right job. In AWS, we have more than 200 services available in our platform. So I will give you a very basic example, which is by using something like a database. We have more than 15 different database options available on AWS. Maybe today you are using a MySQL database or a relational database, and everything is basically operated on top of that database. But maybe you can switch to a non-relational database, maybe a graph database. Maybe you can switch to another optimized database that can give you better performance to that workload. And at the same time, you're more efficient. I'm not wasting any resources, not wasting CPUs I don't need. I'm not wasting memory that I'm not using. And again, goes with the sizing and the auto scaling. So let's say you have a normal website, and maybe at midday, like now, and I know it's like 1:30 now in Egypt. So maybe it's a midday, I have lots of traffic on my website. So I need lots of capacity on my web tier. But at midnight, at 2 a.m., I don't have the same amount of traffic in my website. So how about if I can make my system scale automatically up and down, add more servers and remove servers from my web layer based on how many people are accessing the website, and it's completely automated. I don't have to manually touch it. that will go under performance efficiency, making sure I get the performance that I need while being efficient and I no longer need it. The next pillar is cost optimization, always making sure that you only pay for what you need. Do you really need this? Can this be optimized? Can this be swapped with something else that delivers the same performance but at a lower cost? This is the cost optimization. Recently, we added pillar number 6, sustainability. This is the newest pillar in the edition, and it enhances the framework because we want to provide you with all the best practices for you to consistently measure your architecture against our best practices to improve sustainability. So, and over time, it will eventually help all of us to do our bit towards mitigating the climate crisis and protecting our planet. So I'm sure you have seen this before. This is basically the responsibility model, the shared responsibility model that you have seen, but we are making it more relevant when it comes to sustainability. AWS has some of that responsibility. We design our buildings, we design our servers, and we take care of this from construction to recycling. And we make sure that we purchase the energy, and we make sure that this is a green energy or renewable energy. And we utilize and optimize the way we use resources like water and cooling and all of these things, right? Now, this is the AWS part. But also as designers, as developers, as application owners, you have a part of that responsibility in making some architectural designs about which regions to choose, which services to choose, what even code and code optimizations you can do to optimize the architecture to eventually become more sustainable. Now, I know we will be running out of time very soon, but I will be sharing with you the material, and all of these, of course, will be available online. But I just wanted to share with you some of the best practices around building sustainable workloads in the cloud. Now, if you want to dive deep, of course, we can dive deep into each one of them in a different dedicated session. But when you're building a workload in AWS, always think of how I can optimize this. How can I make sure that I follow the AWS best practices, the latest best practices to increase energy efficiency? A very basic, for example, task you can do starts when you're selecting a region. Even as a basic as selecting a region. Each one of our regions, you'll find this is globally available, have a specific metrics on the renewable energy that we are using. So if selecting a specific region, you don't really care if it's Bahrain or UAE or any other region, you can maybe going for the region that is using the most of the green energy. And that automatically makes your workload run on a green energy and helping with in that architecture choice. So by just choosing a region where we are today at AWS, we are operating at almost 100% of green energy. The second thing you can do, but depends on user behavior pattern. And I think we just explained that. So again, going back to the website example, if I know my users, I don't have a million user at midnight, there is no need to keep the server running 24/7. I can automate my configuration on AWS to enable something like auto scaling to make sure at midnight, automatically the system will shrink the servers in my application to make sure it will save power to be more efficient. So making this choice not only helps you with cost optimization, but it helps you also be more green and more sustainable and use less power. Something like the way you build your software and architecture, something going more into microservices approach that helps you. Data pattern, where is your data? How do you retrieve the data? Are you storing it on hot data, or you can tier it into something like a cold storage if I don't really need it all the time, like backups, and I only retrieve them when I need it. So even making these changes in your design helps you be more efficient, right? So these will be just sample of the things that we can do. I know we could be running out of time. I just want to allow a few minutes if you have maybe for any questions you have about the topic or AWS in general. So if you have any questions, please pop it in the Q&A section. I got the first question here on the chat asking for, is the region changeable? So I'm just going to make sure that I understand the question. As a user of AWS, of course, you have access to all of our regions. And let's say you started today building an application in one of the regions, let's say Bahrain. Now, if you want to move the workload from one region to another region, then this is considered a migration project. I have to migrate from one region to another region. We have lots of migration services. We have server migration service, or SMS. We have database migration service, DMS. We have lots of migration options that helps you move from one region to another region. I hope that makes it clear and answers the question. But of course, you can change the region. A case in point was in 2019, when most of our customers in the region was operating in Ireland. And then when we had the Bahrain region in 2019, many of our customers decided to actually move their workload from Ireland to Bahrain. So they were able to move these workloads to be here in Bahrain. And I believe we will have the same pattern when the UAE region opens as well. We will have customers moving to the UAE region. Okay, very good. A question on the chat: why are you building too many regions? Actually, it's a very interesting question, because I always hear the opposite question is like, why are you not building enough regions? So there are many reasons of having all of this. The number one reason, of course, would be something related to compliance. Many countries will have a specific compliance not to move their data outside the specific borders. So this is why we tend to help them by operating our infrastructure within their compliance boundary. So that could be in the same country, or it could be a union of countries, something like the Gulf have a specific compliance, could be something like the EU have a specific compliance. So just operating within the EU will help. So this is why we are trying to make it. The second reason, of course, is to always be closer to our customers. Having a region in the same country allows you to have much lower latency to access these services compared to having it all over the world in the internet. Let's say in another continent. So making sure you have lower latency and a compliant infrastructure to operate your workload on. Okay, very good. So these are so far the questions. Please do make sure to pop all the questions on the chat. Question on the chat: AWS region design looks more like a blockchain. Very good question. So yes and no, but yes in the idea where I see your point, making sure that the data is distributed in different aspects. Yes, I do have to highlight something, and I know my fellow speakers in the event will make sure that you see this point. But I mentioned that AWS, we have 200 services. A question you always have to ask yourself when you are dealing with AWS, and you can use this with any cloud provider. For every service that you are planning to use, you have to ask yourself one important question. What is the scope of this service? Some services are global services. Global in the sense it operates on top of all the regions, and I don't need to do any replication between the regions. Case in point, something like the identity and access management. This is where you start creating users and permissions. If you go in and under your AWS account and create a user for Mahmoud, then that user is created with a specific password, and I can use this account for all regions. I don't have to create one for every region. So that specific service is a global service, and only few services are like that, on top of all regions. The second option, which is the most common option, is it's a regional level service. So this service operates on the entire region with all the availability zones inside it. Example, something like S3, Simple Storage Service. This is one of the most foundational services we have. We call it S3. And S3, I can use it to upload any objects. So let's say I uploaded an image or a snapshot or anything to S3, and the data on S3 will be replicated across all the availability zones. And I think this is a little bit familiar to the question. So the image is already distributed between the AZs. I don't have to do anything about it. And most of our services are regional. The third option, that some services are AZ specific. AZ specific. So that specific resource will operate in one availability zone only of the region. Case in point, something like an EC2. EC2, Elastic Compute Cloud, is our offering for like a virtual machine. When you power on an EC2, it operates in one availability zone only. Cannot move outside the availability zone. So if one server goes down, it's okay. The EC2 is still up. My instance is still running. If one rack goes down, still running. Once data center is down, I'm still up and running. Because remember, the AZ is more than one data center. But if the entire AZ is offline, then that specific EC2 is offline. Now, going back to the well-architected framework, if I'm building this application for production, I cannot have this. So one of the best practices is to build it as multi-AZ. I need to have one EC2 in availability zone alpha, another EC2 in availability zone beta. So I have at least 2 servers running behind a load balancer between multiple availability zones to become highly available. So the EC2 as a service is AZ level. So every single service, you need to ask yourself global, regional, or AZ. So I hope that answers that question, but you are correct in the way where our services will feel like it's distributed across different servers and different locations to make sure it helps you with resiliency and high availability. Very good, thank you very much. And again, I have a very trick question to you about this. Again, going back to the sustainability, a service I just called like S3. S3 by default is regional. It uses all the 3 availability zones. But let's say you have a specific type of data that you know is not that important. It's not that sensitive. It's just a drift of something that you just want to save it somewhere, and you don't really care if you just lose access for a few minutes. In S3, we have an option to deploy data on 1 availability zone only instead of 3. So being sustainable, right, being more efficient, I can enable this option for this specific portion of my data because I don't need the data to be replicated across all 3 AZs. I will just leave it running on 1 AZ, and it's not that important for me. I'm just putting some data out there, just some files that I no longer need or it's that important. So I hope this is something that you keep in mind. Everything as a decision, you can always consider sustainability as it. Okay. The question is, how can a general user benefit from cloud? Now, as a general user, as just one user, it depends on what you're trying to build. Maybe that user is thinking of creating a startup. You have a very good idea of application or a game, or I just need storage on the cloud, like what you are using with Dropbox and other cloud storage. You can use that as the user. We even have something called free tier. So you can use some of the AWS services within specific limits for free, completely for free, $0 billing. So I believe this is also a very important aspect to take into consideration. How can another user benefit from cloud is by operating workloads on cloud. So all of you, I believe, are working for organizations, and you can see today how is your IT footprint is going. You can see how the bill is going. You can see you want to be part of that climate change, and I want to help the environment. So looking at the data that we have shared today, moving workloads to cloud, meaning 88% less carbon dioxide, this is a very important metric. So you can start considering saying, you know what, if I should just move my workloads to run on the cloud, just moving them without doing any extra enhancements, I could be saving the planet. This is just one option, right? And not speaking about all the other like advantages you can get by running on the cloud. By just moving to cloud, you can become more green and power off your data center. This is just one action that you can take from the presentation today, right? A question on the chat: if I'm having a website on the cloud, would you recommend having the service always on or based on request? So to answer this, 100% a very good question. Thank you for that. So the idea here is all making it as automated and as scalable as possible. So in my head, I would imagine that website is using what we call auto scaling. So in auto scaling, I will operate on the minimum amount of power that I need. And I will enable the feature called auto scaling on AWS that can scale to hundreds of servers if needed, based on specific input. That input could be the CPU load. That input could be how many people are accessing the website. And I know each server can take, let's say, 100 sessions. So automatically, I can see how many sessions is hitting my load balancer, and I keep scaling my web servers accordingly. If the sessions are reduced, then we automatically start reducing the group size to operate at the needed amount. The same for our databases. Our databases are also auto-scalable if you enable this option. So you make sure that every aspect of your application, from a sizing point of view, keeps changing automatically based on the need. Making it running 24/7 doesn't mean it's at the same size, fixed size. I can make it 24/7, but the size keeps changing, becoming auto-scalable. You don't have that flexibility on premises. You don't even have that option on premises, but on the cloud you can. I can configure my web server to be very, very small, 1 CPU, 1 gig RAM if I need it, all the way till hundreds of servers with auto-scaling, right? So make sure you always ping us at AWS if you always have any questions about how you can optimize your design. I know we are running out of time. So I think you are going to be taking a small break, if not mistaken, and then you will be joining my next presenter. We will make sure to have all the questions that you will have answered. Make sure you stay in touch, and thank you for joining the session, and I should be speaking to you later. Thank you for joining, and see you in the next bit.